to number 2.
Recording in progress.
Because they want the unit vector in the direction AB, but they did not give us the vector AB. That's what we need to find first, right? We need to find AB. And just like number 2, we have information to find AB because we know that AB is the same as saying AO plus OB. So yeah, let's do that now. Let's do that. I just need to write this down because I didn't write that down. Okay, cool. I think this is, yes, this is the last question for units vectors. Just to let you know, these questions are past paper questions, and with 3 and 4 marks. So if you were able to do them, you are good to go. So once you're able to complete all those questions there, you finished all the past paper questions on unit vectors, because that's what I do, right? I go through all of them and I pick out the questions for specific topics. So you don't have to go and do it closer to exam time. You just need to get that out of the way. AB is AO plus OB. And of course, we know AO is actually minus OA. You see this? You never know what the marking scheme looks like for your year. So you see this right here, this simple thing from this line to this line saying AO plus OB is the same as minus OA plus OB. For 1 year, you might just skip this and mark some other things, right? But for another year, the mark scheme might have a mark just for writing this, right? So they know that you understand that AO is the same as saying minus OA. That's why it's important for you to write all your steps, right? Don't take anything for granted because you could lose marks, you could lose unnecessary marks, right? And we need you to get as close as total as possible. So just to be safe, because you never know what they're marking, after you write this line, AB is AO plus OB, write minus OA plus OB, okay? Because there is a possibility that they mark this. All right, let me continue now. So minus OA would be minus 3 I hat minus 2 j hat. Then plus OB would be 5 I hat minus 7 j hat. What did Jules do? Minus I hat, this is plus 2j hat, this is plus 5I hat minus 7j hat, which is going to give me minus 3I hat plus 5I hat, that's 2I hat, then 2j hat minus 7j hat, that's minus 5j hat. And this is the vector AB. This is what we would be using to find the unit vector. Everybody good with that?
Yes, miss.
Oh my gosh. Hold on, just give me a second. Anyways. Finding the unit vector, finding the unit vector. So we said because we want the unit vector in the direction of AB, this is the vector we would be using to find the magnitude and all that, right? So first thing, find the magnitude of the vector, which would be the square root of 2 squared plus minus 5 squared, which would give me the square root of 4 plus 25, which is the square root of 29, right? So that's my magnitude. That's the magnitude I'll be using. And then the second step is to substitute it into the formula. So the unit vector is equal to 1 over the magnitude multiplied by the vector. Or some people say the vector divided by the magnitude, same thing, right? So 1 over the magnitude multiplied by the vector, which is this, 2j hat minus 5j hat. And I said you can leave your answer like this because they didn't ask you if it's in a specific form. Or just to be safe, you can write both variations, right? So you write this first, and then you say this is equal to 2 root 29. Wait, why do I have two G's? Oh, this was an I. I hat minus 5 on root 29 J hat. And that's the answer. Everybody good?
Yes, miss.
Thank
Miss,
you.
I have a question, miss.
Hmm.
Since you got the past, like the questions we just did, the 5 of them are unit vectors. But like, it's possible you can tell us the year, or like, you just want us to like not know your year or something.
The only reason I didn't tell you these are past paper questions is because at the beginning, like when you had first joined us, every time I said, okay, time to do past papers, you would freak out. And I didn't like that. So that's why I
Well, miss,
stopped telling
not
you it's
just
past
past papers,
papers.
even the regular questions.
But if you
Yeah.
want, I can tell you the year.
Yeah,
What?
this was all past papers, so yeah. Alright.
I don't know, but like you're breaking up for everybody, breaking up for me. Yeah, all. Hold on, let me just mute this. Dot product, aka scalar product. In order to multiply, okay, so what exactly is this dot product thing? What is a scalar product? Well, in order to multiply vectors, before we were doing scalar multiplication, which was multiplying a vector by a scalar. So just like we were doing just now, let's say I had a half multiplied by 6, 2. This is a scalar value and this is a vector. And then you would say, okay, then the answer is 3, 1, right? That's a scalar value and that's a vector. So that's multiplying a scalar by a vector and it's called scalar multiplication. This though, this is dot product or scalar product and it's multiplying vectors. So for your exam, you would be required to multiply 2 vectors. That's why we use the dot product and the scalar product, right? So say given 2 vectors A and B and they're in column form, right? So the top number is the X component, bottom number is the Y. Same thing for this, right? But obviously I couldn't use the same letters, so I just chose C and D. If they ask you to find the dot product or the scalar product, aka just multiplying the 2 vectors, what you do is that you say the X components multiplied by each other plus the Y components multiplied by each other. That's how you find dot product. And that's it. That's how you multiply vectors. So you say X by C plus Y by D. Do you understand that?
Yes, yes.
Okay, just in case you don't understand what I just said, let's say they gave you 2 vectors, A and B again, They said A is 3, 4, and then B is minus 1, 6. And they asked you to find the dot product. So you would say the x components multiplied by each other. So that's the two top numbers, 3 by minus 1, and then plus the product of the y components. So the y components in this case would be 4 and 6. So that's plus 4 multiplied by 6. And then you simplify. 3 by minus 1 is minus 3. And then 4 by 6 is 24. Minus 3 plus 24 is 21. So notice, whenever you do the dot product or you multiply vectors, your answer is a scalar value. And that's actually why it's called the scalar product, because your answer is a scalar value. And why it's called the dot product is because of this dot right here, right? That dot also means to multiply. Like, I don't know if you've ever seen this before, but there's some people, mostly when you get into like more advanced math, instead of people writing like 3 multiplied by 2 equals 6, sometimes you might see people using a dot instead. So 3.2 is equal to 6. And that's
It's like
basically what this is saying.
matrices.
Huh? Like matrices. Not quite. Not quite.
Miss, basically you just multiply across and then you solve, and then that's like.
Yes, just multiply across and add and multiply across. It's so simple.
So multiply across, add, and then you get your answer, basically.
Multiply the x, add, multiply the y. Okay.
It's so hard about that, miss.
It's nothing.
So why do you
That's
say
what
it's
I'm
so
trying
hard,
to explain
miss?
to you. I don't know. And Troy, you were saying like multiply matrices, and I said not quite. This is nothing. This has nothing to do with add math, right? This is regular math.
I know.
So let's say I had one.
No, I said this is regular math.
Yeah, it's like general
Yeah.
math. If I had two matrices, so you would know this is a 2 by 1 matrix. This is also a 2 by 1 matrix. In order to multiply two matrices, 2 by 1, 2 by 1, this would actually not be valid. Why? Because when I'm multiplying two matrices, these numbers must be the same. So a 2 by 1 matrix cannot be multiplied by a 2 by 1 matrix. But a 2 by 1 matrix can be multiplied by a 1 by 2 matrix. 2 by 1, 1 by 2. These are the same. They must be the same in order to multiply matrices. That's why I said it's not quite like this. Yeah. Just for anybody who was wondering, right? Because I remember I had the same question when I was doing it. That's why it's not like matrices, right? This is very important when multiplying matrices. These are column vectors. It looks like a 2 by 1 matrix, but they're column vectors, not necessarily matrices. Do you understand that?
Yes, it is.
Okay.
Miss, I have 50 possible examples to try.
If what?
Miss, I have only 50 past paper questions to try on that topic.